Hi everyone. I just didn't really feel like you were thoroughly prepared enough to answer some of these questions. From these two, I just want to go over number 18 because it talks about the median, and that's not something we've actually talked about before. Sorry, I'm having issues. So what does the median mean? The median means the 50th percentile. So the median generally means the probability that your random variable x is below whatever the median value is 0.5. Since I would have to integrate to be able to answer this particular problem, what it really means is being less than the median is the 50th percentile. I would have to integrate from 1, because that's the lowest x value on the interval, up until whatever the median is. I guess I'll just call that m. So from 1 until the median of 7x to the negative 8, when I integrate that, it will have a probability of 0.5. The median literally means 50% of the probability lies below and 50% of the probability lies above. So if you just find the probability that 50% lies below, you're good because you're guaranteed that the other 50% lies above. So you don't need to do both. So now you just have to integrate 7x to the negative 8, which will be 7x to the negative 7th over negative 7, from 1 up until the median. This equals 0.5. I'm afraid I'm running out of space. So that cancels, and you get negative x to the negative 7th from 1 to the median equals 0.5. So this is negative 1 over x to the 7th. You substitute the upper bound in and the lower bound in. I didn't really have enough space for this. I apologize. So it's minus negative 1 over 1. That's a negative. So this equals 0.5. Luckily I can make more space. So this ends up being, I guess I'll move it someplace. I'll go up here. So now negative 1 over m to the 7th plus 1 equals 0.5. So if I then subtract 1 on both sides, that does not look right either. You end up with a negative 0.5 because 0.5 minus 1 is negative 0.5. I can get rid of the negative on both sides, so 1 over m to the 7th. It's too small. Let's also keep in mind that 0.5 I can write as 1/2. I think I'm addressing it that way because then m to the 7th would have to equal 2. Does that make sense? I can also cross multiply. So m to the 7th will equal 2. So m is actually the 7th root of 2. I don't happen to have a calculator handy, but maybe I can use my phone. Hold on, I'm trying to calculate. But m is the 7th root of 2. Which is 1.104. So 50% of this thing's probability falls below 1.104, and 50% of the probability falls above 1.104. Believe it or not. Okay, so that is everything for this problem. I'm not that concerned about number 19. I think you can do the same thing, because this is just asking you to find the mean. I'll at least set it up for you. The mean and the median are not the same thing. The median means you are looking for the value for x for which the probability is 0.5. The mean is when you take x times f of x. I'm not going to calculate this one out. I believe you can do the calculus. You would have to distribute the x and the 15 through, and you're integrating, or you can pull a 15 out of the integral, and you're integrating from 0 to 5. But I want to talk more about the normal distribution as well. So here that is on these next few slides. So the normal table is here on the right. I'm gonna have to zoom in and zoom out a few times to be able to get here. Find the proportion of observations of a standard normal distribution that are between the given z-scores. So this is the first thing I really want to call your attention to. Z-scores. Whenever someone discusses a z-score, this always means the standard normal. And standard normal means it's a normal distribution whose mean is 0 and whose standard deviation is 1. Every single time. Z-score always means, I didn't write this quite right. Z is a normal distribution with a mean of 0 and a standard deviation of 1. That's what that always means. So they're telling you that you have the standard normal distribution. They're asking for the probability. Even though they're saying the word proportion, they mean the probability of observations of Z, the standard normal distribution, that fall between 0 and 0.5. So I'm looking for the probability that Z falls between 0 and 0.35. And I've mentioned this before, but I don't know if you paid attention. It doesn't matter if we include the endpoints or not, because the probabilities at any particular single value is 0. So this is equivalent to including the endpoints of 0 and 0.35. You know, the more you try sometimes, the worse it gets. Okay, stop. These two things are equivalent. And all this is asking you to do is to go to the table to answer this question. Oops, I'm just trying to erase. Now, you have to know how to use the table, first of all. So this is a two-step process. We talked about this also briefly in class. If we're looking for the probability of a normal distribution whose mean is 0, which means the center of the distribution is at 0, let me also say the normal distribution is symmetric. So the probability being less than 0 is 0.5 and the probability being greater than 0 is 0.5. This particular problem is asking you to find the probability that the probability of your z-scores falling between 0 and 0.35. I don't really know where 0.35 is, but let's pretend it's there. So these are values along the x-axis, and the probability is actually the area under the curve, so it's what I just shaded. Now, we have to go and look at the normal tables to get these answers. There's no way to integrate this. So I want to be between 0 and 0.35. Now also, I'm sure you don't remember this about the curve, the table. Look at what is drawn right here. The z-table only gives you the probability of being less than a value. So if you go to the other half of this table, this is the negative half of the table, FYI. This is the negative half of the table, and this is the positive half of the table. And you can see that it's still the probability of being less than a positive value. So the area has gotten bigger. So what does this tell you? If you want to find the probability of being between 0 and 0.35, you have to find the probability of being less than 0, which would be, you have to find the probability of being less than 0.35, which would be all of this area, minus the probability of being less than 0, which is just this area. If you subtract the blue region, if you subtract this region away from this region, that will cut out everything we don't want and leave you with just the stuff in the middle. I don't know if that makes any sense. I might try to show it to you a different way. The probability of being less than 0.35 in this original graph that I drew would be all of this. But that's too much. If I then subtract away this region, so I moved that by accident, that would give you just the green region that we actually want. We want just this. So the probability of being between 0 and 0.35 is the probability of being less than 0.35. I can't write today. Minus the probability of being less than 0. So how do we find these from the table? You have to find 0.35 on the outside of the table. So also, let's talk about how this works. 0.35. 0.3 is right here. But that is not sufficient. You have to find 0.35. That's what these guys do. They are not a different number. These are the second decimal. So 0.3 plus 00 is 0.3. 0.3 plus 0.01 is 0.30, 0.31, 0.32, 0.33, 0.34, 0.35. You want 0.35, so you want the number that is right here. 0.6368 is the probability of being less than 0.35. So all the way back here, I hope I remember this number, 0.6365, and the probability of being less than 0. This one should be a little easier. It's 0, and I even already told you what this would look like. But here is 0. And if I go back to the top of the table, 0.00 is exactly 0, and 50% of the probability lies below 0. So this is 0.6365 minus 0.5, which is 0.1365.